Today we are going to look at exponents and what they represent. And so let's take a look at our first set of directions. Asks us to multiply. So we've got a number and an exponent. So let's talk real quick about a little bit of vocabulary with regards to exponents and the number that we're raising to a power. And so this 4 is called the base. And the exponent is the number in the upper right hand corner, and that number tells us how many times we're going to end up multiplying the base. So this number, if we multiplied it out, would represent 4 times 4, or 16, and that's the number that we're looking for. So all the base tells us is the number that we're going to multiply. The exponent tells us how many times we're going to multiply that base. So for instance, here the base is 2, exponent's 3. So we're going to take that 2 and I'm going to multiply it the number of times the exponent tells me. So 3 times. And so when I do that, typically I group these two numbers together and I get 4. And then 4 times 2 makes 8. So that's my answer. Well, here we have an exponent of 0. Now a lot of people want to say the answer is 0, but it's not. And the reason is this, and so later on we'll see why, but I'll give you an example of this problem here. Let's say we had, and we'll use the number 7 instead of 3. Let's say we had 7 to the first power over 7 to the first power. Well, when you go ahead and divide these, you end up with 7 divided by 7 makes 1. Well, the reason they have this 0 as the exponent is because later on you're going to learn a rule with exponents. And the rule is that when we have the same base and we have a fraction bar, we subtract the exponents. And so they end up with 7 to the 0 power. But we already learned earlier in the problem up here that if we do the division, 7 goes into 7 one time. So that means that any number to the 0 power is just going to always be 1. Well, here we have an exponent of 1. Well, that just means we have 1 9 being multiplied. But there's no other 9s to multiply, so the answer is just 9. Over here we have 3 as the base, 5 as the exponent. So I'm going to multiply 5 3's all together. Well, 2 3's make 9. 2 more 3's make 9, and then I just bring down this final 3. And so I multiply the two 9's, I end up with 81. 81 times 3 makes 243, and that would be my answer. Well, the next set of directions asks us to use an exponent and the given base to write each number. Well, this is the number they're talking about right here. So we're trying to write the number 25 using the base of 5 and an exponent. But they don't give us the exponent, so that's the part that we're trying to look for. So 5 is the base. So the base is like the 4 here, or the 2 here, or the 7 here. The exponent is the number we're looking for. So that's the question. And it equals 25. So how many 5's should I multiply together to make 25? Well, 5 times 5 makes 25. And so that means we have 2 5's. So that means our answer is 5 to the second power. And that's what we're looking for. What exponent do they want us to use? On this next one, they're looking for a base of 4. So we start with 4. We're looking for the exponent of 4 that makes 64. So we think of how many 4's do we have to multiply together to make 64. So let's try doing it. 2 4's, we know that makes 16. So we need to continue to multiply other 4's. So let's try multiplying one more 4. When we multiply one more 4, we get 64. We get the number we want. So that's our answer. How many 4's is that? There's 1, 2, 3 4's. So our exponent is going to be 3. So that's what we're looking for there. 4 to the third power. Over here, we have a base of 2. So we'll start with the 2. And then we're looking for the exponent that equals 8. So we just start multiplying some 2's. Let's do 2 2's. We know that makes 4, so we need another 2. Bring that down, and when we multiply it by the 4, we get 8. So we'll count up how many 2's we multiplied. We had 1, 2, 3. So it's 2 to the third power. That's our answer. Well, here we have a base of 3, an exponent that we're looking for, and equals 3. Well, how many 3's does it take to equal 3? Just 1. That's it. Only 1 3 to make 3. So that means that our answer is 3 to the first power right there. 3 to the first power. Well, another set of directions you might see is one that asks us to compare. And so when we compare numbers, we use these symbols. Now, if I'm reading from left to right, so from left to the right, I look at the inequality sign, and if it points to me to start with as I read from left to right, I read that as less than. Now, if I read the other way, I would read it as greater than. But this symbol, typically we read from left to right, so if I read from the left to the right, it's open to the left, so that means it's greater than. And then equals is just the two lines. So what we need to do is we need to be able to have the same type of number. So we need to write this 7 squared without exponents. We need to multiply it together. So this is the same thing as 7 times 7, which is 49. And I see 49 is greater than 48. So my answer is 49 is greater than, or 7 to the second power is greater than. Over here I have 3 9's being multiplied. So 2 of them make 81, times 1 more 9, and that gives me 729. Well, 729 is less than 810, so my answer is less than. Over here we have 4 6's being multiplied. And so we'll go ahead and multiply 2 6's, make 36. 2 more 6's make another 36. So we have to multiply 36 times 36. Well, when you do that, you get 1296, 1,296. Now, how about 10 to the third? There's a quick way of doing these. And so you'll see it after we do this example, and we'll be able to do this next one a lot faster. Notice that 10 times 10 is 100. And then when you multiply by another 10, it just adds another 0. So it makes 1,000. So notice that the exponent tells us how many of these zeros we need. We have 3 zeros, and that's the exponent that you have. So if you have 10 to a power, take a look at what that power is, and that's the number of zeros that go after the 1. So in this case, 1,296 is greater than 10 to the third. And so what they're kind of showing you here is that the number 6 is smaller than 10, but because there's more exponents, we're multiplying more numbers, that's why the answer is a little bit bigger than the other one. Well, let's see this one. This is 10 to the 6th. So that means that we have 6 zeros. 6 zeros. And so if I was to write that out, that would be 1 million. So that's what it would look like. And that is bigger than this number of 100,000. Now, another way we could have done it is we could have written this as an exponent. So count the zeros. You have 1, 2, 3, 4, 5. So that's the same thing as 10 to the 5th, which is still smaller than 10 to the 6th. Well, we've got a couple word problems. So just look at what they're saying here about Jesse. On the first day, Jesse has $2. Second day, he has twice as much money as the first day. And the third day, he has twice as much money as the second day. So all we're going to do is do 2 times 2 times 2. And they want us to write the amount of money on the third day in exponential form. So that would be 2 to the third power. Then write the answer in standard form. Standard form is just 8. So standard form, they just want the number just like that, 8. So 2 to the third power and 8 is the amount of money that he has, so $8. Let's take a look at our last one here. Kevin runs 5 miles on Monday, so 5 miles on Monday. And the total number of miles he runs that week is 5 times the number that he runs on Monday. 5 times just means you're going to multiply 5 by 5. That gives us 25. So 25 miles is the number of miles he runs. Or we could write that as 5 to the second. So those are the types of problems you're going to see on tonight's homework. Good luck.